to the programming part of looping. Programming part. Here we will discuss simple programs related to the loops, repetition, iteration. So let us create a new file. Let us create a new file. Let us call it as, let us save it first. So some downloads. So ex3.c. Okay, I saved it. Hash include stdio.h integer main, and within this you have this say return 0. Okay, now what program we are going to write? Let us write program to add say 10 numbers first. To add numbers from 1 to 10. How do you do it? I want to add numbers from 1 to 10. How do you do it? You can have just simple variable, say integer sum, which is initialized to 0. And what I can do is, I can write like this: sum equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. I can write like this, and I can just print the value of the sum. Print the value of sum is say percentage %d sum. Okay, let us try it. Build it. Okay, fine, fantastic. Executed. So the value of sum is 55. Okay, fine, it worked. Now what happens if you want to add say 100 numbers, 1000 numbers, or you want to add say n numbers? How to do it? You cannot write statement like this. You cannot write 1 plus 2 plus dash to 1000. It's difficult. So what you can do? Probably for the first we'll try for only 10 numbers. So instead of writing the program like this, we can write like this. Say I equal to 1, some variable I equal to 1, index variable. We'll use while loop first initially. We'll use while loop. While I less than or equal to 10, what you can do? You have to add. What you have to add? Sum equal to sum plus what? See, what you have to add? 1, 2, 3, 4 up to 10. So I equal to 1, initial value is I1. Now if I add it, if I add I, sum equal to sum plus 1. Next I value will get incremented. We have to increment it, and then I value becomes 2. We can add the again I. So like that we can add. So what we can do? So within the loop, sum equal to sum plus I equal to I plus 1. In short form, you can write plus of I if you want. Okay, like this you can write. Okay, put it in the comments, or if you can, if you want, you can remove it. Okay, so I equal to 1, while I less than or equal to 10, sum equal to sum plus I equal to I plus 1. Let us build it. Maybe we have to declare I also. Okay, now okay, fine, execute. So same value. The value of sum is 55. Now the beauty here is in the first case, if you want to add say 1000 numbers, you have to write like this. So it is difficult to write, it is error prone, somewhere you may miss some number, so it is difficult. So if we write loop like this, if we want to add 1000 numbers, then I can just write like this, simple build and then execute. So fine, I am getting the result. So it is simple. So you can do it using the while loop like this. Or if you want, you can do the same using for loop. You can use the same using for loop. So for, you can write for. I am not going to write the for statement here. We will discuss other examples, but I will just put it in the comments. What you can write for I equal to 1. That means we will bring this statement inside the loop. For I equal to 1, I say less than or equal to whatever it be, say 1000. Okay, 1000 plus of I, or I equal to I plus 1. So like that. Again, you can write sum equal to sum plus I. This statement is not again needed because already this statement is present here within the for loop. If you use for loop, you will write it in a compact form. Everything comes within the loop, within that for statement. Okay, body of the loop will contain only other statements. Everything comes, say, in the header of the for itself. You can write like that. So this is the advantage of looping. Okay. Now one question. So I less than or equal to 1000. So outside this loop, what is the value of I? If you print, say, if you print the value of I, the value of I is, what is the value of I that will be printed? Can you guess? What is the value of I that will be printed? Can you guess? So this, as long as I is less than or equal to 1000, we will be executing. When we come out of this loop, when I value becomes, because I equal to I plus 1, when I value becomes 1000 plus 1, that is 1001. Okay, 1001. When I value becomes 1001, we come out of the loop. So at this point, it should be 1001. Let us try it. So you can see the value of I is 1001. 1001. Note that point. Note that point. Okay, now we will improve it. Now instead of using for loop, we will use while loop. Instead of using while loop, we will use for loop. Okay, instead of using while loop, we will use for loop, because I want to illustrate the working of for loop also. Okay, so I'll remove this one also. Same in the case, the value of I will after the loop will be 1001. Okay, if you want, you can check it. So here you can see you are getting the same result, no problem. And in some cases, some compilers allow the declaration of I here itself. Let me check within the loop also. That is called as scope and lifetime. That comes under scope and lifetime. Let me check whether this compiler supports it or not. So fine, it is supporting. So if the compilers are supporting, whenever you are using the variables, declare the variables as close as possible to their use, because here we are using the I, here within the for loop we are using the I, we are not using I here. So you declare it here, you can declare like this, you can declare like this. So that's the best thing, that's the best thing. Okay, now we'll do the modified version. We will declare here itself to avoid any confusion. So we'll declare like that only. Now what I want to do is, instead of adding thousand numbers, I want to add n numbers, first n numbers. So this is the program for adding, remember, first n numbers. First n numbers. What do you mean by first n numbers? First n numbers means from 1 to n. 1 plus 2 plus 3 like that. So we will declare some n also, and let us read the value of n. So enter the value of n. Remember again, the printf statement is not mandatory. It is only for information sake. Without it also, it will wait for you. It will not display anything like enter the value of n. You can just give the value of n. That is implied. So for convenience you are using. So it's better to use. Okay. How do you read the value of n? What should be before the value of n? Before n, what should be the value? What should be the symbol? So you have to supply the address. You have to supply the address in the case of scanf. So it should be ampersand n. Now instead of 1000 we have n. Let us see. Let us compile first. Okay. Execute. Now what is the value of n? What is the value of n? So you can give any value, say 20. So 20. The value of sum is 210. So that means 1 plus 2 plus dash to 20 are added, and the value is 210. And the value is 210. Okay, and the value is 210. And the value is 210. So you can give any value of n. Okay. Now let us check some extreme cases. Now suppose I give the value of n as 1. What happens? N is 1 only. What is the sum? I value will be 1. I less than or equal to 1. Yes, 1 is less than or equal to 1. It's true. So the statement will be executed once. Sum equal to sum plus I, that is 1. Sum equal to sum plus 1. Sum is initially 0. 0 plus 1, it is 1. So sum will be 1. Next, I value will be incremented. I value will be incremented. Okay. I value becomes 2. I less than or equal to 1. That is 2 less than or equal to 1. It is false. So it will come out. So sum, what is present in the sum? Sum is 1 only. Let us check. So the value of sum is 1. The value of sum is 1. Now we are saying that this will be initialized and then condition is checked. Let us try to check whether it is working in the same way or not. Now what I do is, instead of giving the value of n as 1, I give it as 0. I give it 0. Is it correct? So I give it 0. So I value will be 1. I value will be 1. What I am saying, the condition will also be checked. So I less than or equal to n. I less than or equal to n. So 1 less than or equal to 0. Is it true? False. That means it will not enter the loop. It will not enter the loop means, so nothing is added. That means some value should remain 0. You can see the value of sum is 0. So like this, you try to play. Learning programming is not about typing the programs from the textbook and then executing. You play with it. You should enjoy. You should enjoy. Then only you get programming skill. Then only you get programming skill. So this is the best way of learning. We experimented, or in fact I experimented with the first year students. So we found that the online method of teaching the program by directly typing it in the computer, using the computer, is the best way, rather than writing it on the blackboard, or showing it entirely in the form of slides. So all those things are okay, but this is the best way of learning. Now we'll continue. Okay. Now I am adding the first n values. Now I don't want to add first n values. I want to add n values. Whatever may be the value. That means, so n value, say if n is 5, so I have to enter 5 values. Those 5 values can be anything: 1, 5, minus 10, or 20, 30, 40, like that. Some 5 values I have to enter. So depending on the value of n, okay, n values I have to enter, and then they have to be added. Now that means here you are not adding I. Every time you have to read the value and then add that value. You have to read the value and add that value. So let us call that value as x. Okay. Now what I can do here, within the loop, before adding, you can write printf statement, or I will write only scanf here, %d and x. So I will write only scanf here. That means every time I am reading the value of, while I goes from 1 to n, every time I am reading the value of x, every time I may give new value, and then I will add it. To print the message, you can do it here, because the numbers I can enter one by one. Every time I need not again print it and then read the number. So instead I can write enter the values to be added. Okay, this you can do. Okay, now let us build it. Okay, fine, everything is going fine. Now enter the value of n, say 5. I can add any values. Now enter the values to be added. Initially, let us say I will add only 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the value of sum is 15. Okay, so like that I can add. Now the second case, I will give some random numbers. I will say again 5. Value of n is 5. So I will give 1. Okay, and then say 5, and then say 10, and then say again minus 5. You can give negative values also. Say minus 10. So 5 values I have given. What is the sum? So when they are added, you will get 1. Okay, 5 minus 5 gets cancelled, 10 minus 10 gets cancelled, only 1. Okay, press any key to continue. So fine, you can add numbers like that. We'll give random numbers. So build, execute, give random numbers. Say 10 numbers. I will give some random numbers. Random numbers we don't generally give, because we don't know the sum, we cannot verify it, but anyhow. So you can see it is working. We have to calculate, if you want to verify the result, we have to actually calculate it. But let us, because it worked for all the other cases, we will assume that it is also working for this case. So the value of sum is minus 4650, minus 4650. Okay, minus 4650. So this is regarding adding n numbers. Regarding adding n numbers, what else we can do? What else we can do? We have to use both this break and continue. So we will go with the adding of only positive numbers. N numbers are there. N numbers are there. Okay, you will be given n numbers. Those n numbers can be positive or negative. If it is a negative number, you should not add it. If it is a negative number, you should not add it. But all the positive numbers are to be added. All the positive numbers are to be added. So what I can do now? So again I am reading the value of x, but I should not add if the value of x is negative. I should not add if the value of x is negative. Negative means if x is less than 0, it is taken as negative. If x is less than 0, it is taken as negative. If x is less than 0, what I have to do? I should not add it. So what I can do? Now what I have to do exactly? I should not add it. That means I should not execute this statement. I should bypass this statement. I should not execute this statement. I should bypass this statement. How do you bypass? Bypass using continue. Okay, continue. So let us check it. We will give the same values, previous values, 1, 5, 10, minus 5, okay, minus 10. So what we are doing now? In the previous case we added all. Now we should not add negative numbers. That means minus 5, minus 10 should not be added. Okay, but 1, 5, 10 are to be added. 1, 5, 10 are to be added. You can see here 16. We will change the order, because you may say that they are at the end. They are at the end. We don't know whether minus 10 is considered or not. So we will give in the random order. Or in fact, we will give the numbers at the beginning. Minus 10 is given, minus 5 is given, and then 1, 5, 10 are given. So same result. Same result. So that means we have used continue statement. So whenever continue statement is executed, the remaining statements within the loop, these are the statements, the remaining statements within the loop are bypassed. That means they are not executed. Now we take the other case. We don't want to bypass. So whenever negative number is encountered, we want to come out of the loop. If negative number is encountered, we will come out of the loop. How we can do it? Come out of the loop. You can do it using break. Okay, I will write break here, build it, and then execute it. So again 5, say 1, 5, 10, minus 5. So here you can see. So as soon as we entered negative number, it is coming out of the loop. But positive numbers are added. Okay. Now let us give the negative number at the beginning itself. Then what happens? So 5, say some minus 5. So it is immediately coming out. That means whenever negative number is given, so you are coming out of the loop. You are coming out of the loop. So continue actually bypasses the remaining statements and then again goes and checks the condition. Whereas break immediately takes you out of the loop. So it goes to this. The value of sum is whatever the value that is accumulated within sum, that will be printed. Okay. That will be printed. Let me check whether video recording is happening. It again got stuck. There is some issue. Okay, you can neglect. The video is not required for this one. The value of sum is printed. So we have discussed while loop, for loop, break, and also continue. For loop, break, and continue. Now, what is the other case? Any other programs? We can discuss many programs actually. We can discuss many programs. Let us do this do while statement. Do while statement. Do while. Let me just illustrate it. We do not take bigger examples. Okay. Let me type the program. So do while I less than equal to 10, sum equal to sum plus I. Okay, again integer sum equal to 0, fine. I we will declare. Okay, now what we are doing here. So we are adding the value of I equal to initially say 1, I equal to 1. So sum equal to sum plus I, sum equal to sum plus I, sum equal to sum plus I. Okay, sum equal to sum plus I. Sorry, not sum equal to sum plus I here. Here it should be I equal to I plus 1. Let me try to compile it to find any errors. No errors. So execute. Press any continue. We have. Why we got this one? Why nothing has happened? Can you guess? Nothing is printed. Why? Because we are not printed actually. There is no printf statement here. No printf statement. So what you have to do? Print the value of sum. The value of sum is, so percentage %d sum. So you can see the sum of the first 10 numbers is done. Sum of the first 10 numbers is done using do while. The only thing is this will be executed at least once. So this will be executed at least once. If we try to add n values, then what happens? It will be executed at least once. That means some value will not be 0. Some value will be at least 1. So in the case of do while, these statements are executed at least once. So that is the difference between while and do while. Okay, so you can just satisfy yourself with this simple example. We don't generally use do while. We don't use do while. It's not necessary. It's not necessary. Okay, but remember how it works. Remember how it works. That's all. So this regarding do while loops we discussed. So we'll be using these loops regularly for all the programs. We'll be using the loops. So we'll come back to these loops. We'll come back to these loops again and again, again and again. So we'll stop the session here. Thank you. But this is important. So from the after this, because we are discussing the loop, we will discuss next session switch statement. So after that, you can write huge number of programs. So you can start writing your own programs. But please remember, don't copy from the book. Write your own programs. Let it be simple programs. 2 numbers addition, 3 numbers addition, finding maximum between 2 numbers. Let there be simple programs, trivial programs, but write on your own. You just frame your own problem, write the program, check it. So don't copy from any book. Thank you.